we are going to learn how to determine the sum and products of roots of a quadratic equation. Yes, you heard me right, a quadratic equation. Okay? So that's what we're going to do, and let's see how that plays out. Okay? So the first thing is for us to recall the general representation of a quadratic equation, given as ax squared plus bx plus c all equal to 0. Whereas, so far, a is not equal to 0. Okay? Yes. That's the general representation. Along the line, if we go further, we discover that x, the roots of the equation, can be represented as x is equal to minus b plus upon minus square roots b squared minus 4ac all over 2a. Yes, this is the formula method, okay? Or the formula representation of this quadratic equation. So we can use this to solve any quadratic equation and obtain roots. No problem, but there is something we need to do here. Look at this. Plus upon minus. It means that this, we have both positive and negative values as its roots. In other words, we are going to have x1 to represent alpha, okay? We are going to have x2 to represent beta, so to say. Well, what do we do? How do we get that? That's the question. How do we get all of this? Let's begin. It's very, very important. Let's begin. So first of all, let's split this into x1. It goes with positive first. All right? We split again into x2. It goes with negative. That's what we need to do. So let's do that quickly. So x1 is going to be, we retain our minus b, right? Okay? And then plus goes first, roots, square roots, b squared minus 4ac all over 2a. That's the first one. Alright, semicolon. The second one, x2, is going to be minus b minus square roots b squared minus 4ac all over 2a. We have two roots now, x1 and x2. Alright? Take notes. Don't forget anything. Try to understand the steps we are outlining one at a time. Alright, so let's look at it very well. This compound factor, this factor has to be replaced with something meaningful. So let's say that b squared minus 4ac represents or is replaced with the capital letter D. Let's replace all of this. So anywhere we see this, b squared minus 4ac, instead of writing it, we write capital D, bold letter D. The same thing applies here. Okay? So let's understand that. We are going to do it at this point, we are going to do it at this point also. So let's look at that. But before we move on, we should also know that x1 represents alpha as a root, okay? x2 represents beta, or rather we are using alpha to represent x1 as one of the roots, and then beta to represent x2 as one of the roots of the quadratic equation. If we have understood this, we move on from there. We can now move this way, and from there move this way. Or we can move to this point first of all. Let's move on to this point. Let's look at this section. Since we have decided to use alpha to represent x1, we can now say, once again, okay, there's no need. We can now say alpha alpha, right, is equal to that baggage is equal to minus b plus square root. Instead of writing all this, we write d. Okay? D all over 2a. That's the first thing. That is the first thing. Then the second one is for x2. Our x2 now is beta. So we write beta is equal to minus b. Instead of minus, we go with minus square root capital D all over 2a. That is it. Look at it. That is it. This is a, please. Okay? That is it. Very simple. All right, we have now identified two important factors or two important components of the equation, alpha and beta, representing the roots of the quadratic equation, so to say. Now, how do we then get the sum? How do we get the sum and at the same time get the products? Okay, how do we get the sum and then at the same time get the products? That is where our concern lies. That is where our interest lies. We are going to look at the sum. So we can now specify that our next target is to find the sum. Okay? The sum of this should be, if we non-add, sum simply means if we add alpha and beta, what do we get? That's what it means. If we sum this, alpha and beta combined, but using the operator plus, what do we get? So let's see what we're going to get. Let's see. For alpha, we have minus b plus root d, okay? And then all over 2a, our operating sign here is plus. So we put plus. For beta, we have minus, okay? b minus root d all over 2a. Good. Take notes. Of course, you know what will happen next? We find the LCM. Let's quickly find the LCM at this point. Oh, it's like it's too tight. It's going to be too tight there. So let's just try alpha plus beta. We are looking at the LCM, and the LCM of 2a and 2a, this is 2a and 2a. The LCM of 2a and 2a is still 2a. No, it's like I'm squeezing things up here. Let's see once again how it goes. Is 2a, okay? That's the LCM. So let's see what happens. We take it from there to this side. So we now have that alpha plus beta, we have an LCM which is given as 2a, right? It means that 2a divided 2a is 1, multiply this. We still retain minus b plus root d. And the same thing happens there. If we say 2 divided 2a, it's still 1 times all that. And we have plus, remember we have minus, b minus root d. Good, and close. This sounds interesting. Okay? Alright, so we have this. So what do we do? Very simple. Let's clear out. Collect like times, clear out, and we're done. So we continue with it. Sum alpha plus beta is equal to minus b plus square root capital D. This we normalize, becomes minus b, becomes again minus square root d, right? And all over 2a. That's it. Watch. That is it. Let's see which one will go. Of course, plus square root d and minus square root d will go. This vanishes instantly. and we're left with minus b, and minus b all over 2a. Therefore, alpha and beta, summation of the two, will give us minus b all over 2a. And this boils down to, or rather reduces to minus, and then 2b all over 2a. Correct? Something is important here. Something is common. 2 is common. Let's go again. It implies that alpha plus beta is equal to this. We cancel out. And we are left with just b minus, please. Let me write it well. So that we don't get confused while using this. Minus, because there is minus there, b, all right, all over a. So take note. Bravo! We have successfully found the sum of the roots of a quadratic equation. That is it. So with that, we can find the sum of the roots of a quadratic equation. But something is remaining. The products. How do we get the products?